So today we are going to discuss about oxidizing agents and reducing agents, definitely. So first of all, we recall our previous sporting lecture from periodic table. These two codes we have studied, Lumber and Rona. They tell you the feature of oxidizing and reducing agent, L for metal left and M for metal, B for basic, and R for reducing agent. Similarly, means R for right, and then O for oxidizing agent and oxidizing agent, N for non-metal, and A for acidic. So anyhow, okay, what we have got that metals are reducing agent. What we have got from this code that metals are reducing agent. They are present on the left side and they form. So who are on the left side? It means group 1. Group 2 are definitely a good example of reducing agent. Group 1 is alkali metal and group 2 is alkaline earth metal, right? Okay. And what are on the right side of the periodic table? These are famous halogens, group 7. So they are famous as oxidizing agent. They are non-metal, they form acids and all that. Okay. So now the second point, after that you will be able to understand the concept. The second point is compounds. You need to understand compounds that oxidize. Compounds that oxidize. Oxidize means oxidation process. They are reducing agent. So this is the keyword. If you have found the oxidation process in any element, it means it is acting as a reducing agent. Got it? And what is the reverse of that? Compound, element, or anything. Compound that reduce are the reduction process. That undergo reduction. You may say that undergo reduction. It will be behaving as oxidizing agent. So you no need to do some more works if you continue the previous process. For example, if I am writing this equation and I am asking you to find oxidizing agent and reducing agent from the following. So what we are going to do, what is the charge on zinc? Nothing, so 0. And what is the charge on HCl? H is +1 and Cl is -1. Okay. And what is the charge on Cl in the compound? It's -1 into 2 become -2. And zinc is +2. Zinc would be 2 plus or +2. And H2, nothing is there, so similar 0. So what we have learned so far, zinc is going from 0 to +2, and I am saying oxidation process is occurring in it.
That's true. Yeah.
Right? And what I am noticing about the Cl, it's going from, sorry, I am wrong. What I am considering hydrogen, it is going from +1 to 0.
0.
So what we say, reduction is occurring in hydrogen.
Hydrogen,
So zinc is undergoing oxidation process. So zinc will be called as reducing agent. Okay. What I told you, the compound that will oxidize will be behaving as reducing agent. Got it?
Yeah.
And the second one is not HCl. No doubt in HCl, hydrogen is basically undergoing reduction process, but HCl will be called as
reduction.
HCl will be called as oxidizing agent. This is we are going to study today the identification process based on your previous lecture. Okay, all the steps are from the previous lecture. Okay, look at the definition of oxidizing agent. So what it says, an oxidizing agent is a substance that allows oxidation to happen by gaining electron itself. Okay, that actually reduces itself. I repeat, who is oxidizing agent? Simply those who reduces itself, those who gains the electron. For example, what I have told you for the concept that the halogens are oxidizing agent, right?
Yeah.
This is the thing what I have told you. So what are the examples of halogen? That Cl. What is the charge on Cl? -1 usually when it gains electron. So what the charge halogens are getting? So it means halogens are undergoing the process of reduction and behaving as oxidizing agent. So repeat with me, beta. What does which process halogens are undergoing? Oxidation or reduction? Reduction. And which type of agent halogens will be called as?
Oxidation.
No, not oxidation. Oxidizing agent. There is a big difference between oxidation and oxidizing agent. Okay? Oxidation is a process. Okay? And oxidizing agent is the nature of a compound. Okay? So what does oxidizing agent is? If you see over here, it is a substance that allows oxidation to happen by gaining electron itself. Oxidizing agent always gains the electron, like halogens is gaining electron, receiving electron. Got the point?
Yeah.
Okay?
Yeah.
So, any question?
No.
So far, any question? So what, okay,
No.
if I ask you simply, what does, which process happens in oxidizing agents? What you will say?
They're going through reduction.
Yes, they are going through reduction process. And where does oxidizing agent exist in periodic table? On right side or
On
left
the right
side, oxidizing agent?
Right side.
Oh my God, yes, you are right. So oxidizing agent are on the right side. So what kind of elements in the periodic table, metals or non-metal? They, which elements behave as oxidizing? Yeah, non-metals. So, okay, if I ask you further, what is the nature of the acids? Does the acids are oxidizing agent or reducing agent?
Oxidizing agents.
Okay. Okay, that's right. And what about reducing agent, you know?
They're on the left side of the periodic table and they're metals.
On the left side of the metals and they are reducing agents. Very right, Shabash. So, what are the famous oxidizing agents we use in laboratory? Here is the list. We have oxygen, which we use in the combustion and respiration process. Okay, for the potassium permanganate, you need to just have a look for the memorization. In titration process, potassium permanganate, the formula is KMnO4. So we are going to definitely study in titration process. Sodium dichromate, hydrogen peroxide. All these are famous oxidizing agents, which we use in the laboratory. So even in the swimming pool, what we add to kill germs, we add HCl. Okay, and here HCl act as HCl is an acid. So HCl is an acid. So HCl will act as which agent?
Oxidizing.
Yeah, that is the code Rona, right side, oxidizing agent, non-metal and acids. You can easily answer the question, right?
Yeah.
And why we are adding HCl? Why we are adding HCl in the swimming pool? To kill all the germs
kill the
in swimming pool,
microorganisms.
right?
Yeah.
Done with that. So reducing agent. So have a look at the definition of reducing agent, beta. So what does reducing agent do? Reducing agent is a substance that allows reduction to happen by losing electron itself. Okay?
Yeah.
They lose the electron by themselves. So he has identified
Okay.
magnesium is 0, magnesium is 2 plus over here. So magnesium is
Yeah.
undergoing oxidation process. So magnesium is a reducing agent, right?
Reducing agent. Yeah.
Clear?
Yeah.
So what are the common reducing agents? Sulfur dioxide, carbon, carbon monoxide, hydrogen in different compounds.
Yeah.
So here is an example for you. You need to, and the answer is there, so you can solve.
Yeah. Yeah.
So quickly, what is meant by oxidizing agent? We just discussed. Name 2 oxidizing agent. Even you can name 5, 10. Okay, no worries for you, inshallah. What is meant by reducing agent? Name 2 reducing agent. And question number 8, you are going to solve and then send it to me, okay, as a homework.
Okay.
Okay. So halogens. Halogens on the right side of the periodic table. Halogens include which elements? Fluorine, chlorine, bromine, and iodine. The famous. So how they behave? They behave as
oxidizing agents.
If I ask you, among the halogens, who is the strongest oxidizing? No doubt, all the halogens are oxidizing agents, but one would be the stronger oxidizing agent, and one of them would be the poor oxidizing agent. So how you are going to rate it? Yes, beta. So the answer would be fluorine. Always keep in mind, fluorine is the strongest oxidizing agent. Chlorine is weaker than fluorine, bromine is weaker than chlorine, and iodine is the weakest halogen oxidizing agent among the halogen, right?
Yeah.
So who is the strongest? Fluorine.
Fluorine.
Okay.
Yeah.
So why fluorine is a stronger oxidizing agent? Number 1, fluorine has small size. Fluorine has only 2 shells. Chlorine has 3, bromine 4, iodine 5. So chlorine has small size.
Yeah.
Okay. It has high electronegativity. High electronegativity value, and we are going to discuss in future in detail of electronegativity. Okay. And these 2 features makes them a strong oxidizing agent. Okay.
Yeah.
So this is one he is writing over here. Fluorine is the most powerful of all oxidizing agents and oxidizes chloride, bromide, and iodide to free halogen. Oh, this is we are going to discuss a very important topic. If fluorine is going to be a stronger oxidizing agent, then how it can control or it can disturb. For example, if fluorine is stronger oxidizing agent, if it reacts with KCl, what it will do with the KCl? It is going to break the bond of KCl, and then you would have KF plus Cl2. What fluorine did? Fluorine broke the bond of chlorine compound and makes it bond. Okay? Makes it bond by its own. Got it? So similarly, even fluorine is even such a stronger agent than bromine and iodine. It can break the bond of all the compound which are present below them. Okay? But what will happen? Let's see if I give you a task like this. Bromine plus KCl. Does bromine can break the bond of compound of chloride? Any chlorine? The answer is no.
No.
Why? Because bromine is a poor oxidizing agent than chlorine.
Yeah.
So in short, this is a very, very important thing. Chlorine can break the bond of bromine. Chlorine can break the bond of iodine. But chlorine cannot break the bond of fluorine. The answer is no reaction. Okay, unreactive. But in reverse of that, if you are going to react fluorine with KCl, even K is just a common factor. It could be NaCl, MgCl2, anything, just a chloride compound. The answer would be yes, fluorine is going to break the bond. Okay.
Yeah.
So what you have learned about the power of oxidizing agent among the halogen. So you explain, please.
The fluorine is the most powerful oxidizing agent. Then it's chlorine, bromine, and iodine. And if fluorine can break the bond of all the other ones, but chlorine can't break the bond of fluorine. It's less powerful.
So to iodine, if iodine want to break the bond of any compound, want to displace, so to which halogen iodine can displace?
It can't break any bond.
It can't. It can only wish, but can't do anything, right?
Yeah.
Why?
Because less powerful.
Yeah, weaker, not less powerful. Say weaker oxidizing agent. No power, no? Okay. So these are the all examples which we have discussed. Okay. So generally, so far from here, it's the new topic. Here is chlorine with the iodine, bromine with the iodine, and all that. So here chlorine reacts with the sulfite ion. So look at this reaction. Cl2 plus SO3 minus 2 minus, it should be plus water. Okay. And we have 2Cl minus plus SO4 minus 2 plus 2H positive. Okay. Now you can easily identify Cl2 is 0 and here is minus 1. What happening in chlorine? Reduction. That is right. And very confusing. How you are going to check SO3 minus 2 is going to SO4 minus 2? How you are going to study whether definitely you have got the point that reduction is occurring in chlorine. Okay?
Yeah.
So chlorine is behaving as an oxidizing agent. You have got it. So it's for sure if reduction is occurring in the chlorine, then oxidation process is definitely occurring. So you have read the definition of oxidation as addition of oxygen, right?
Yeah.
What was the one of the definition of oxidation? I just want to prove that oxidation is occurring over here in one way. Here you have 3 oxygen and in the product side you have 4 oxygen. What it means? Addition of oxygen. But we are also going to discuss how many electrons in the charge. So how to find the charge on sulfur? Look at this. If it is SO3, total charge is minus 2, not 0. The total charge of this compound is SO3 is minus 2, not 0. Okay. For example, many a time we have studied many compounds and I told you if no charge is given, then we are taking charge as 0, right?
0.
But in the case, if minus 2, minus 1, plus 1, anything is given, then the net charge would be taken as 0. Got the point?
Yeah.
So we don't know the charge of sulfur, but we know the charge of oxygen. And total value is minus 2. In this way, I can find the charge of sulfur, and that would be plus 4. So here the sulfur is plus 4 and oxygen is minus 6, and we are getting minus 2 answer, right?
Yeah.
Why oxygen is minus 6? You know that it is 3 into minus 2.
3 plus 2. Yeah.
Got it? -2 on the.
Yeah.
Okay. What is the charge on sulfur in SO4? Total charge is -2, right?
Yep.
So here I am going to write, beta, the charge of sulfur as X. I don't know. 4 oxygen charge on each oxygen is -2. It is going to be -2. So X -8 equal to -2. It is becoming X equal to +6, right? So
+8. Yeah,
look at this. This is going to be +6. Here it is -8. So what is changing in the sulfur? Sulfur is changing from +4 to +6. So how many electron they are losing? 2 electron.
2.
Because when the charge was +4 and it will lose 1 electron, the charge would be +5, and then it will lose 1 more electron, then charge will be +6. Okay, this is what. Look at this. He is writing the equation. Okay, very interesting. He is writing it -2 electron, and I am writing +2 electron. Are these the same thing or the different thing? These are the same thing, beta. If I am going to mathematically want to shift over here, this plus will be converted into minus. If you are going to, in oxidation reaction, if you are putting the electron on the product side, it is going to be positive 2 electron. If it is, you are writing, if you are planning to write on the reactant side, then it would be -2 electron. Okay?
Okay.
So, any question?